everybody, welcome to new video. In this lesson, we're gonna to teach when our limit is infinite divided to infinite, or our limit is limit 0 divided to limit 0, how many methods we can solve the problem. One of the method is asymptotically equivalence, and another one and powerful of one is L'Hopital. What's the L'Hopital exactly, guys? For example, when you have limit fx divided to gx, x goes to a, b infinite divided to infinite, or limit 0 divided to limit 0. Therefore, if you are in indeterminate form, you can calculate it by L'Hopital. How this work? You calculate the derivative of numerator is f prime x, and derivative of denominator is g prime x, and after that you take a limit and put the point, and answer is exactly is the value of the limit. For example, I'm gonna to solve this simple question with two methods. At the first, from the equivalence relation in the limit, we go and we spoke about these materials, of course, in the previous course, and you can follow it. When sinus cycle and cycle goes to the 0 is equivalence to the cycle. Therefore, the sinus to x goes to 0. This circle goes to 0 and is equivalence to 2x, and therefore the bottom of that is 2x, and in the denominator is x, and they can cancel each other, and immediately we take 2. But right now I'm gonna to solve this problem with L'Hopital law. We know this factor derivative is 1, but the sine 2x, we know the sine u is u prime cosine u. Therefore, 2x prime is 2, therefore is 2 cosine 2x. Therefore, the limit x goes to 0. Immediately we can calculate. When x goes to 0, cosine is 1, and 2 times 1 is 2, divided to 1 is 2, and therefore they are the same. Okay. But another question. This question I'm going to solve with limit method, because when you put the 1 in the denominator, 1 minus 3 plus 2 is 0, is limit 0, and in the top, 1 plus 5 minus 7 plus 1 is 0. Therefore, we can use the L'Hopital law. In the top, 3x2 plus 10x minus 7 and 2x minus 3. Right now, limit x goes to 1. Therefore, in the top, 13 minus 7 is 6, but 2 minus 3 is minus 1, and answer is minus 6. But another question. Tangent x minus 1, x minus pi over 4, when x goes to pi over 4. In the top is answer is 0, and in the bottom also is limit 0, and therefore we can use the L'Hopital. In the bottom is so simple, because this factor, when you take a derivative, answer is 1, but we know the tangent derivative is 1 plus tangent x power 2. Therefore, we substitute this here, and this is a number, and the derivative of number is 0. Therefore, the limit x goes to pi over 4. We know the tangent in the pi over 4 is 1, and therefore answer is 1 power 2, and total answer is 2. But notice, keep going. Sometimes it's happen after one step you put the L'Hopital, and also you achieve to limit 0 divided to limit 0. If the calculation is not so hard, you keep going to the second step and don't quit the operation at the first one. For example, in here, although the bottom and the top, when I put the 1, is limit 0, and if I calculate 3x2 and I take a derivative plus 4x minus 7 divided to 3x2 minus 3. Right now I take a limit, x goes to 1. Although in here we put the 1, we again take to the limit 0 divided to limit 0. But we must keep going, because after that this indeterminate form will happen and we can solve it. Therefore 6x2 and in the top 6x plus 4, and answer in the top is a 10, 6, and we divide to 2 is 5/3. But another question, guys. Before we go to another type, I must tell you an important notice. Sometimes you come to some questions, and these questions you receive to 0 times infinity. We have a strategy to solve these questions. We put this type of question to infinite divided to infinite, or 0 limit divided to 0 limit. But how? For example, if one factors, for example, they have a two side, yes? One of them is fx and is 0, and another factor, when you put the limit in it is infinite. Exactly the same. This is 0, limit 0, and this is infinity. How we can solve these problems? By keep change flip law. For example, if we keep fx and flip jx, and after that take a limit, x goes to a, we know we achieve to limit 0 to limit 0 over limit 0. But if we keep the jx and change flip the fx, we achieve to infinity divided to infinity, and is our previous method, and we can solve with L'Hopital and equivalence relation, and like this. For example, this question, limit x times ln x, x goes to positive 0. You know how is the graph of ln x? Ln x is exactly the same. When x is positive is minus infinity, therefore minus infinity cross 0. I told you we can use the keep change flip law. Therefore I prefer to keep ln x and change x, it turn to 1 over x, and x goes to positive 0, and right now is infinity divided to infinity. And right now we can use the L'Hopital law, and this derivative is 1 over x, and this derivative, this part of formula is minus 1x power 2, and if we cross this part and put in the top is x, and if we cross this part and x2 and we put in the bottom is minus x, and answer is minus x. Right now limit x goes to positive 0, and answer is 0, guys. Okay, let's go to the another question. The limit x minus pi over 2 times tangent x, when x goes to pi over 2 in left side, because I don't gonna to split to the both side and calculate the both side of this. Okay, this is when you put pi over 2 in the left side, this is 0 and this is infinity, and therefore I prefer to keep this parameter, therefore x minus pi over 2 divided to 1 tangent x. Right now limit x goes to pi over 2 minus, you know, 1 divided to tangent is cotangent x, therefore x minus pi over 2 limit x goes to pi over 2 in the left side. Therefore, we can use the L'Hopital law, and in the top is 1, but we know the derivative of cotangent is minus 1 plus cotangent x power 2, and the limit x goes to pi over 2, and we know the cotangent in the pi over 2 is 0, and answer is 1 minus 1 plus 0 over 2, and answer is minus 1, the total answer. But another notice is equivalence law when x goes to the 0 or when x goes to the infinity. When x goes to the 0, you must select the minimum power. Therefore, for example, in this part, when x goes to the 0, I just select this one and is equivalence with 3x. Or another one, in here, the minimum power is minus 3x and therefore is equivalence with 3x when x goes to the 0. But that formula is what when x goes to the infinity, you must select the powerful, the most power of this every formula. For example, in here, the maximum power is 3, and we just select this sentence and is x3, 3x3, and in here the powerful is here and is 4x power 6. Okay, the last question. When the limit of this formula, when x goes to the infinity, we know from equivalence relation, everything from the powerful in the bottom is exactly 5 over x power 3, and in here is x power 3, and answer is 5. But in here, when x exactly the same, but x goes to 0, we know we must use and select the minimum power, and minimum power is here 120x, in here is minus 3x, and answer is 40. Thank you guys for watching this video, and please subscribe our channel and take your suggestion in the comment. Bye bye.